Hello, and welcome to today's video, which is going to be investigating polynomials with graphs. You guys don't really know what a polynomial is, but we will define that. But I'm going to just throw this word around a lot. Basically, a polynomial is just a stringing of number patterns. So I'll explain what that means as we work along today. Okay, so what we're going to do in this video is I'm going to make sure that you have your GeoGebra set up. I'm going to show you the assignment, which is right here on this web page here. So if you wanted to, you can download this right now, which is this Word document, Investigating Polynomials. Okay, so you're going to click the download that Word document, get that ready to go. This is also a file we're going to be using. This is a GeoGebra file. I'm trying it out. Excuse me, to share this file with you on my website, and I think this will work great. Don't click on that yet, though. Don't download that yet until you know that you have GeoGebra installed, because your computer won't know what that file is until you do have GeoGebra. And then once you have GeoGebra, you can just download it, and it should open right up into GeoGebra. Okay. If it doesn't, we'll go about I'll show you how you can go about that if it doesn't. Okay, but you should have your Word document downloaded. We're going to come back to this site to get that GeoGebra file, but let's make sure we have GeoGebra installed. So you're going to click on the Mr. Bowers Math website link here. Takes you back to my home page. Okay, another trick of a computer here is to get GeoGebra and not leave my website. You can just right-click a link and open link in new tab. Just click on that and it creates a new link. You don't have to leave my website, and there's GeoGebra. You're also going to need Dropbox, so you might as well right-click Dropbox and open a new tab as well. Okay, so go to your GeoGebra.org tab and go through the free software and then install GeoGebra on your machine. Okay, make sure that you have GeoGebra up and running. Alright, we'll go back to Dropbox at the end. That's where you're going to upload your assignment. Okay, so now that you have GeoGebra installed, so you might want to pause and make sure that or go through the video, kind of check out what's going to happen as that's installing. You know, come back to this point in the video right now. Maybe I'll switch over to GeoGebra right now, but come back to this point here when you get everything ready to go, and at this point in the video I'm going to continue the lesson here. Okay, so oh, by the way, you need to go back to my website now that you have GeoGebra installed, and click on the Algebra 1 link again, and then at the bottom of this Algebra 1 page you're going to now download. Don't click on the name because you can't actually on this file. You're going to click download. Okay, make sure that this says open with and then the Java Web Start Launcher. That's how we know that it recognizes it as a GeoGebra file, and then if you click on that, it'll open it in GeoGebra. If it doesn't, just right click or click the download and then go to save file and then save that somewhere where you can get that file. Because then all you have to do is go to your GeoGebra window and then go to open and open that file. Okay, so now that you've got your GeoGebra file open, this is what it looks like. And right now you're like, oh my gosh, what is going on here? Okay, now I'm tying this in with your Word document or your homework from yesterday, which looks like this. This is your Word document that you just pulled up. Okay, the exact same worksheet. What we're going to do in this video is we're going to graph these four, well actually, we're going to take a look at these graphs. I already have them graphed for you and all the points from your tables, which we'll take a look at that in the GeoGebra file. Okay, but based off of these number patterns, where you take a number and square it, or you just take a number and really do nothing to it, doesn't matter what we put in, you're always going to get out some number or constant. And then also cubing a number. Okay, these are four different number patterns, and we're going to look at what's called a polynomial, which is really like a stringing together or operations on these different number patterns. Okay, so like this, for instance, where f of x is x squared, and g of x is just x, that is an example of a polynomial. This is an example of a polynomial where we have some kind of function added to another function, then added to or subtracted to another function. Okay, so what I refer to as polynomials will be these functions that we're going to be talking about. Okay, let's get a little familiar with the GeoGebra file. On your Word document, on those front 4 number patterns there, I have those tables in the spreadsheet on the right. I color coordinated the everything as far as green, purple, orange, and blue. Those are going to be our 4 functions. So the first function, f of x, is this x squared function. So here are those input values we used. So when you square these, like -3 squared is 9, -2 squared is 4, and so forth, this would be your table that you have on your worksheet. Now next to it, I have the g of x being the x function. That's here in purple. And with those same input values, here are those matching. Whatever you put in, that's what you get out. Right? So that's what this column is showing, is the outputs for our g of x pattern, which is just our x function. Okay, now h of x is orange. This is the function where it doesn't matter whatever you put in. It doesn't matter if you put in -3, -2, -1, any of these inputs or any other ones. We're always going to get out a 3, which is just a horizontal line, which you should have graphed. Okay, and then the r of x, where we take in a number and we cube it. So -3 cubed, -3 times -3 times -3 is -27, and so forth. Here's our column, our output for that. So in this little spreadsheet, I have your 4 tables really put together. Okay, so again, each one's color coordinated. If you look at the algebra window on the left, in the functions here, we have the 4 functions. These are the graphs. Like if you look at f of x, which is x squared, this will be the graph of it, okay, of that number pattern, okay, and then so forth. That's what the functions are, the graphs. Okay, the lists are the actual points from the table. I already got them entered. So if you click on, say, for example, we have to get these the actual points here, which are also color coordinated. We have to get those shown. Notice right now I turned everything off as far as visibility. Those circles are white. So remember, to see things, all we have to do is click on those toggle buttons there. Notice we get our points and everything to show up. Okay, so let's take a look at x squared, okay, real quick. Your graph, let's just make sure that your graphs that you graphed on your assignment match the actual graph. So from your table here, let's look at what these points do as far as the number pattern is concerned. Okay, so everywhere, every point that's green here under point, click on that. These are all your points from the table. Okay, this should be what your number pattern did, right? Now we use the function, the graph here. If you click on that to show it, that's putting in all sorts of input values. Remember, we're only looking at these special points right here, right? We only put in a -3, we only put in -2, -1, 0, 1, 2, and 3, right? So those are the only points we're looking at. The graph, though, is every other infinite number in between all those inputs and everything beyond. Okay? So now here's what we're going to do. We're going to look at graphs as a way visually to show us the relationship between outputs of functions. Okay? Now what I mean by that is this. Let's just have your window showing here like mine, where you have f of x and all of its points showing. So the green points in the green function are toggled on over here. Here's really what happens when we look at functions, when we put in numbers. Since this is really how the numbers, whatever we put in, whatever number we squared, these are our x values, right? So we put in a -1, we squared it, -1 times -1, we got out a 1, right? Really what we want to look at is, when we look at these cases, this is really what the output is when we graph it. The y coordinate tells us how far, like a distance, how far off of the x-axis each input is, right? So let's take a look at when x is -3. We're going to use the tools of GeoGebra to investigate some things here. So in this fourth toolbox up here, you're going to click the drop-down arrow and click on parallel line. So you get the parallel line tool. Now let's investigate, let's use this graph to really take the time to see what happens when x equals -3 and how it relates to this graph here. Okay, so this point that we have here, notice as I highlight it on the algebra window right here, it's highlighted as well. So when I click on that point, what I want to do is I want to create a vertical line right here. This x equals -3 line, right? Remember, when x equals -3, that's a vertical. So we want the point to go through at this, or the vertical line to intersect at this point. So we're going to make sure our tool is selected. You're going to click on that point, and now to make sure that it is vertical, I'm going to make it parallel to the y-axis. So I'm going to click on the y-axis here, and notice now it gives us a nice vertical line. So that is, and if you look at the algebra, it's highlighted right here that this is our new line. It's the x equals -3, right? Anytime x equals a number is a vertical line. All right, now where x equals -3, notice it intercepts our graph at this point. Okay, but I'm curious what this length of this, like, if you were to think of this as a segment, if we only look from this point to the x-axis, I wonder what the length of that is. And if you think about it, we're going from 0, as far as the y-axis is concerned, all the way to 9. That has a length of 9, right? Okay, so I only want to look at that segment. So what we can do is, let's go ahead and grab your intersect tool. So in the second toolbox, we're going to click the drop-down arrow. You're going to highlight the intersect two objects tool, and then you're just going to click on the x-axis and that line. Notice that gives us a point down here. Okay, so now what I want to do is I want to hide my x equals -3 line. So select your move tool, click on that to turn off the x equals -3 line, and now we're going to grab our segment tool real quick. So our segment between 2 points tool, click on that, and let's just create this segment right here. Notice when I do that, the segment, which is down at the bottom of our algebra window, now that we made it, B, which is the name of this segment, GeoGebra is calling it, it's equal to a length of 9, right? That's our output for that point. So when we put in a -3, that's where the line is at -3, we got out this 9, right? So we would go up 9 units. So that would be the length of that segment. So if I were to do a segment when we put in a -2, so you could either do the intersect tool, or if you click on your segment between 2 points tool again, just click on -2 on the x-axis and it'll create a point right there, and then click up to point B, and we have that segment, right? It's also vertical, and notice it's going to call that segment C. It has a length of 4, and that is the output, right? So that when we put in a -2, that's why we go over -2 on the x-axis and we go up a distance of 4. That segment has a length of 4. Okay, so create segments for all of our inputs. 0, let's leave that alone for right now. But all these other segments here, if you ever get a point that turns blue like I just did, okay, you can grab that and move it. So it didn't lock on the x-axis. So that dark blue means it's free moving. You can do whatever you want with it. So I'm going to actually delete that. These kind of purplish points, when you do a purple point, it means that you can move it, but it's confined to something like the x-axis. So if you ever get a blue one like I got, that's not set correctly. So I'm going to grab my segment tool again. I'm just going to make this segment. Okay, there, it's purple. I know it's good. And purple. Okay, so what we just did there was we created these segments that are really showing the output values at these inputs, right? When we put in a 1, we have a length of an output of 1. You put in a 2, we have an output of 4. Okay, now let's even go to where, let's click on this angle icon here. Click on that down arrow, and we want to click on the distance or length tool. So get that tool selected, and now just click on each of these lengths, and we'll even put the output right next to it. Okay, so it just showed us the length of those segments. Now, what we're doing is, I hope you can understand that based off the values I gave you, whatever you put into the function is what we move over on the x-axis. What we get out is that length, or that distance from the x-axis. That's our output, and that length is always going to be equal to that output value. Okay? So that might help us if we think about outputs as like a length from the x-axis, like a distance from the x-axis. Then when we look at things like number 5 on your worksheet, this first polynomial that says take those outputs of f of x and subtract from them the outputs of g of x. Okay? Well, if these are the outputs of f of x, these lines here, let's look at the outputs of g of x. Okay, so let's get these lines that we just put in here, let's make them green so that they're associated to our f of x function. So if you notice down at the bottom of your algebra window, all these segments we made, as you highlight over them, you can see them highlight on your screen. All these segments, or you can just click segment, which will highlight all of them. You want to click segment, and if you right click and do object properties, let's make these green, the same green as everything else, which I believe is this one. Okay, now notice those segments are green. Okay, so now here's what we're going to do. Let's hide all those, let's hide all the green stuff right now, and let's just pull up our g of x function. Since we're going to really look at the polynomial, I'm going to write it right here. We're looking at number 5, which is, I believe, I thought I could draw on this. Sorry. Number 5 on your worksheets in front of you, f of x minus g of x. So g of x is the x function. Okay, so let's make sure that all of our green stuff now is hidden. Segments, points, everything. I'm sure there's a better way of going about it. I'm just going about clicking every single thing. Okay. These points on your x-axis, you can leave them there actually, because we're going to use those for segments. Since we're using the same inputs, we're going to use these same points here, and you'll see what I mean. Okay, now let's go ahead and show our g of x function, which is just this line right here. Okay. All right. Now let's do the same thing that we just did. And actually, I want to see those points that we have from our table here. So let's plot those ordered pairs. So every point on here that's purple, we want to see it. So all these purple points on your algebra window, select those. Okay, there's our inputs from -3 to 3. That's what our number pattern does, and we connect that number pattern with our graph. Now let's look at those outputs as lengths. Now notice as we put in -3, we get out a -3 because that's what our number pattern does. Okay, those distances, even though distances can't be negative, that is a distance of 3 from the x-axis. But for now, we're going to consider that to have a negative value because it is in the negative direction. Okay, now this is a -2 distance, -1. This is a distance of +1, +2, and +3. So let's go ahead and show the values of these distances, these lengths, right? Click your distance or length tool and select on them, or just click on them, and it's just going to tell us. Now, we might have an issue here. I'm working along with you, and I'm just talking and thinking as this video is going on. I'm thinking because these are an actual distance, which can't be negative, we have to still consider these a negative distance because they're in the negative direction. Even though GeoGebra doesn't identify them, distance is always positive. So if we come up with an issue, we'll confront it then because they're not negatives. But you'll see what I mean, I think, a little bit later. Let's go ahead and make these purple. Okay, so go back down to your segments, all your new black segments. So you can just click on the top black segment, hold your shift button down, and click the last one, and it'll highlight everything. Right click, object properties, we need to make these purple. Okay, so now let's go ahead and hide all of our purple stuff. If you have multiple things selected, you can just click show object when you right click them, and that'll uncheck multiple things. Okay, so make sure all your purple stuff now is not shown. Oops, and I missed a segment. How come that's not purple? Oh, there's a segment up there. Okay, so now we've got our f of x with our kind of our distances, or those output lengths shown, okay, for both f of x and g of x. So now this concept of subtracting. So what this is really saying is we're going to take those output lengths, we're going to subtract them from the lengths, those output lengths of our f of x. So we're going to take those g of x outputs, those segments that have those output values, and subtract those lengths from the lengths of f of x. Okay, so watch this. Here's what we're going to do. We're not going to show our functions. We're going to show those output lengths that we had for putting in a -3, -2, -1, and all these 7 points, right, from our table. Let's show those outputs as segments now. So all these segments that we have, show your green ones. Okay, these were our output. So if you need to move around, just grab your Move Graphics tool. Let's even zoom out a little bit. I'm going to zoom out. So if you hit the drop down arrow here, let's zoom out. Okay, now there's our number patterns, right? Based off of just looking at the outputs. Okay, so if you grab your Move Graphics, you can move around. This is really, you can see our pattern in here, right? Okay, so now I'm going to also show the purple segments. Okay, now what we're going to do though is our function says z of x says we're going to take these output values of f of x, these green values, and we're going to subtract off of them these output values from g of x, the purple function. So let's look at the positive one here, this positive 3. We got an output of 9, right? If we put 3 into our f of x, look at this, we got out a 9, and we subtracted from it the g of x when we put in a 3, which was 3, right? So our z of x is going to be this output minus this output. Okay, let's actually have the spreadsheet calculate that column for us. So let's title F1. You're going to use your quotes again. Use quotes, sorry, to title this, which is z of x, I believe, from the worksheet, is equal to f of x minus g of x. Let's go ahead and type that in that cell, hit, and then end your quotes, and then hit enter. So it has z of x there, okay? And I might even extend that cell. If you grab that line over here, it'll make that cursor turn to an arrow, and you can move it. Okay, so now what we're going to do here is we're going to say this cell is equal to the output values of f of x. So we're going to click this cell B2, this output here. Okay, I'm going to go back to this here. We're going to take, and from our B2, we're going to subtract from it what is in C2. So I'm going to click in C2. That's our g of x, and hit enter. Okay. Now we got 12 here. Here you should have got 12 on your work. Now here's why this is going to be an issue here. This should be a -3 length, although GeoGebra again calls it 3. Understand that because that's negative, when we subtract a negative, it's like adding a value, right? So the length of that segment, when we subtract off a negative, it really makes this length of 12. Okay, so what I'm going to do is let's create some segments. Okay, so grab your move tool here. Oh, actually, let me finish up the table. Sorry, I'm getting excited. Click on that F2 cell that you have 12 in. Grab that blue box there, move it down. These are the outputs that you should get Okay, 12, 6, 2, 0, 0, 2, and 6. Why do we have two zeros? Well, if we look at this, we're taking our f of x for, so when we put in a 0 into f of x, we got out a 0, and we're subtracting it from our g of x when we put in a 0, which is 0. So 0 minus 0 is just 0. And then we take the output, when we put in a 1 into f of x, we get out a 1, and we are subtracting this one. So we get two zeros here. Okay, it's just making sure that this makes sense. Okay, so now let's look at the distance concept here and how they match up with these numbers. This 9, because we're subtracting a negative, makes it adding this 3, has a length of 12. So what I'm going to do is go back, grab your move cursor tool, click on the white here so we get our options back, and let's create a length, a segment with a length of 12, because I know that when I take this 9 minus a negative 3, we have to consider, remember this is negative 3, 9 minus negative 3 makes us a length of 12. So I'm going to click on this point right here and bring up a segment here of 12. Okay? Alright, now look at this here. We have this length of 4, and we're going to subtract from it this negative 2 length, right? This output of negative 2. So 4 minus negative 2 means we're really adding 2 to 4. So that gives us a length of 6. Okay, so let's put that point there. These new blue points that are coming up, by the way, these are going to be mapping out what z of x really is, your graph that you got. Okay, so now we got this length of 1. We're going to subtract from it this length of negative 1, which means we're going to add 1 to 1 and give us a length of 2. So I'm going to try to make a vertical line, length of 2. Okay, it's 0. This is where we got out of 0. So really we only need to put a point there. The second toolbox is your new point tool. So just click on this drop arrow, new point tool, and let's put it at 0. Also at 1, when we put in a 1, we also got out of 0. Okay, so let's put that there. Okay, now let's go ahead and grab our segment tool again. At 2, f of x was 4. We got out of 4. 2 squared is 4. Let's subtract off this positive length now. Okay, so now that we're in the positive, subtraction does what we expect it to. 4 minus 1 gives us a length of 3. So I'm going to grab my segment tool and create a point at 3. And then when we put in a 3, in f of x we got out of 9. When we put in a 3 in g of x we got out of 3. So 9 minus 3 is 6. So the length of a new segment here, when we subtract those values, is a length of 6. Okay, so now we have these new points and these new black links here. Okay, let's go ahead and put in what z of x really is. And all we have to do is say z of x is equal to, in our input bar here, z of x is equal to f of x minus g of x. Okay, so now if we hit enter, notice we get this new graph, and it hits all of our points here that we would expect it to. Let's see, why was that point off? 2, 2. Oh yeah, we get out of 2, excuse me, at 2. I had that point at the wrong spot. Okay. So, notice those lengths are our new function, right? So we took these output lengths, and our function z of x says we're going to subtract 2 lengths here. Okay? If you look at number 6, it's saying take those output lengths of r of x, whatever those lengths are, and then divide them by 3. Okay? This one says take those output lengths of g of x and multiply those lengths by 4. So they're going to quadruple in size. Okay, and then this one says take f of x, add to it that 4 times those g of x length values, and subtract from those lengths the lengths of h of x. Okay, so what I want you to do for the remainder of the period here is I want you to show me that your z of x, or your new polynomial functions, the remaining 3 on your second page, are really going to be the lengths of all of our segments here. So what you can do to make this easier on yourself. So, like on number 6 here, you're going to show r of x divided by 3. You only need the r of x function. So you want to unselect everything and make sure that all your r of x stuff, which is the purple, or excuse me, the blue things, are shown. You're going to create those segments to show me the output lengths, right? And then in the spreadsheet here, create the new column of all those output values of z of x. You're going to have the g, the h, and the I filled with the 3 remaining polynomial functions. Okay. Now, what I recommend though from you have your new investigating polynomials activity GeoGebra file. You can go ahead and I would say maybe save this as a new file in your documents. You know, maybe somewhere in there. You're going to click save. Okay. The reason. Well, let's see here. Maybe not. Maybe we don't want to do that. Excuse me. I'm trying to make this easy on you because you're going to get a lot of extra stuff in here. I guess you're just going to have to unselect everything and then just select everything you want to see. So unselect everything showing and make sure all your blue is showing. Okay. And then I want you to visually demo, like I walked you through here, what each polynomial is doing as far as outputs. Okay, that's what I want you to think about when you do these kind of polynomials. Think about outputs. Okay, so if that gets confusing to you, please go back and follow through what I did again, looking at output lengths in GeoGebra. Okay, and then you're just going to show everything. So what I would do is print screen. Like this is number 5. So you're going to hit print screen. Yours isn't going to do anything because of my computer. I have a green shot program. You're going to hit print screen. Whoops. Okay. Yours, again, like I said, won't do anything. Mine does something weird, so I'm just going to copy the clipboard real quick. Now, what I would do for number 5, let's delete these tables and graphs here, and I want you to paste your screenshot. And just shrink it enough to where you can get, it's the same layout, it's just the screenshot of your graphs. Okay? So again, when you go through and you get each one made, hit print screen, just print or paste over these. Okay? So you're going to have your print screen for each of these polynomials. Okay? I hope that makes sense. If it doesn't, again, please try to go through the video at least one more time. If it doesn't make sense, then ask me. I will ask you in class if you have done that. So learn to rewind and take something in again. Okay? So anyways, good luck on this activity. Now when you're done, by the way, when you're done, you're going to go to File, Save As, save this document somewhere you can get to it with your name on it. Just your name is good enough. And then that Dropbox website we opened up earlier, you're going to put in that username, password info, get into Dropbox. So in Algebra 1, the only folder we have, Polynomials Activity, and then click on your period, and then, like if your first period, for example, and then upload your document. Okay? So that is the activity. I hope this video wasn't too boring and didn't take too long. Get the remaining problems done.